Good morning, everybody. We're going to start talking today about greatest common factor again, but using ladder method. We previously have talked about finding the greatest common factor using prime factorization. I think you're going to like the ladder method. So if you'll pull up your handout 5, scroll down just a tad. I've done an example for you. This first example, 16 and 40, you probably know the largest number that divides evenly into 16 and 40 just by looking at it. It's pretty simple. Some will know it, some won't, but it's 8. Even on the ones where we know what it is, we're still going to practice the ladder because practice will improve our skills, and then when we get a problem where we're not sure what it is, we can do the ladder to make sure. So let's scroll down. When you do the ladder method, you're not concerned any longer with prime numbers. You're just concerned with what the two numbers have in common. So you write the two numbers horizontally, doesn't matter the order, and you pick any number that divides evenly into 16 and 40. I could have used 2, I could have used 4, I chose 8. The ladder is shorter if you start with the largest number you can think of. 8 into 16 and 40 goes 2 times and 5 times. You know you're through with the ladder when 2 and 5 don't have anything in common other than 1. So the GCF is always the vertical part of the ladder. Now I just drew this little L shape around it. We'll be talking more about the L shape when we get to least common multiple. You don't have to draw the L shape. That's just up to you. So the greatest common factor in this case is just 8. Notice right here it says multiply the values in only the vertical part of the L shape. This being the vertical part. So let's take a look at another example. Find the greatest common factor of 16 and 40. It's the same example, but I started with 2, just to show you how the ladder can continue. So I wrote over here just what happens. 2 goes into 8 4 times, 2 goes into just all the division. So if you start with 2, 2 goes into 16, 8. 2 goes into 40, 20, and then I put another layer in my ladder, or a rung if you will, and I draw my ladder here. I divide 2 into 8 goes 4 times, 2 into 20 goes 10. Get rid of that right there. 2 one more time, 2 goes into 4 twice, 2 goes into 10 5 times. So you only multiply the vertical part of the ladder. So this 2 down on the bottom, that's not part of the vertical part of the L. That would be the horizontal part of the L. So 2 times 2 times 2 is 8. I do want to see what you're multiplying together. So in the case above, there was no multiplication because there was only one thing in the vertical L. But here, there are 3 things, so you will show what you're multiplying together, and then box your result. I did a third example here. This one might be a little bit harder to see at the beginning if you're not 100% sure. So they're both even, so I factored out a 2. 2 goes into 52 26 times, 2 goes into 36 18 times. Factored out a 2 again, 2 goes into 26 13, 2 into 18 9 times. I'm not stopping because 13 is prime, but because 13 and 9 have no other factor in common other than 1. I stopped drawing the L shape, but I can still see it mentally, and I made a note right here. Draw it if it helps you. So the vertical part of the L are these 2 2's. 2 times 2 is 4. You really need to show this support right here. Now, sometimes you get two numbers and they actually don't have anything in common. So when you see 7 and 12, sometimes people have an instinct to say there is no GCF, but there is always a GCF. Sometimes it's just the number 1. If I had to make a ladder on this one, the only thing I can factor out is 1. 1 goes into 7 7 times, 1 goes into 12 12 times. So you can see the GCF is 1. There's really no use in making a ladder on a problem like this. So it's important to note, and let's just highlight, let's just highlight that. Well, let's highlight this. Be careful saying things like there's no GCF. It will just be the number 1. Okay, so I'm going to ask you right here, just to pause the video, try the next couple of examples, and then go back to the video to see how you're doing. Okay, I've written the numbers horizontally. Remember, you can start with any number you'd like. I noticed they both end in 0, so I'm going to start with 10. Goes into 80 8 times, goes into 180 18 times. Add another rung to the ladder. They're both even, so I'll factor out a 2. Goes into 8 4, goes into 18 9 times. I stop here, because 4 and 9 only have 1 in common. 4 and 9 have only the number 1 as a common factor. So you're going to multiply color. You're going to multiply what's in the vertical part. So your GCF is 10 times 2, which is 20. Most students find that they prefer the ladder over prime factorization, but you do need to know both for your assessments. One good reason to know 2 methods rather than 1 is if you're asked to work it one way, you could work it the other way to verify your answer, to be sure of yourself. Let's see how you did on number 6. So these numbers are a little larger. Not sure what number you chose to start with. I would notice that they are both divisible by 4, because this number ends in 56, which is divisible by 4, and 32 is divisible by 4. But I'm going to guess that most people started with a 2. So 2 into 156 is 78 times, and 2 into 132 66 times. Yes. And then I noticed both of these are they're actually both divisible by 3, because 7 plus 8 is 15 and 6 plus 6 is 12, but I'm going to guess most people picked a 2 again. That would give us 39, and 2 into 66, whoops, is 33. (39) and 33 are both divisible by 3. 3 times 13 is 39. Remember, 3 plus 9 is 12. 12 is divisible by 3, so we know 39 is. And 3 into 33 is 11. So we're only multiplying the numbers in the vertical part of the L. So the GCF is 2 times 2 times 3. 2 times 2 times 3 is 4 times 3, which is 12. If you want to put the interim step of 4 times 3, that's great. It's not really necessary here. All right, Well, our last two examples are of three numbers. You have some problems on your homework where you have three numbers to find the GCF for it. So let's do this one together, and then maybe you could practice the last one on your own. You really don't do anything differently. You just list all three numbers side by side, skip a little space in between, and then just take your time because the numbers are larger. Well, it starts with all numbers that end in 0, so I think I'll factor out a 10. So I get 90. 10 into 600 would be 60. 10 into 450 would be 45. Take another rung on your ladder. Each one of these is divisible by 5, or you might factor out a 3. I think I'll do 3. It's a little easier division. 3 into 90, 30. 3 into 60, 20. 3 into 45 is 15. Then I would divide a 5, factor out 5. 5 goes into 36, 5 into 24, 5 into 15, 3. I stop here because 6, 4, and 3 have no other common factors other than 1. So we multiply 10 times 3 times 5 to get our GCF. 10 times 3 times 5. And different people's ladders are going to have different order in the vertical part. That's perfectly fine. You get 150. It's always a good idea to check and kind of visually look and make sure that your answer makes sense. For example, if you got a number that was larger than your smallest number, you would know that something went wrong, because 450, if it was a factor, you couldn't have one any bigger than that to go into 450. Okay. If you want to pause the video here and try this one, that's great. You can do that now. And then I'm just going to go ahead and work it. So pause it if you want to practice on your own, which I think that's a great idea. All right, 144, 64. It really doesn't matter what order you list the numbers when you get ready to start your ladder. When you see this one, you should notice that they're all divisible by 4, but you're really just trying to do easy division. So if I factor out a 2, I can see easily that that's 72, 32, half of 200 is 100, half of 56 is 28. Another rung. You could divide, 4 goes into each of these numbers, but you could still divide by 2. You might see that a little bit better. So half of 12 is 6, half of 8 is 4. Now I recognize that 4 divides evenly into all, or I could keep dividing by 2. I'll use a 4. 9, 4, and 16. 9, 4, and 16. 4 and 16 have a factor in common, but 9, 4, and 16 do not. So you stop there. You're ready to multiply everything in the vertical part of the L. So GCF equals 2 times 2 times 4, which is 16. And that, my friends, is a wrap for greatest common factor using the ladder method. See you next time.